This is section 10.3, geometric sequence and series. Write the first 6 terms of the geometric sequence with first term 12 and common ratio 1/2. The first term is 12, and then we just keep multiplying by 1/2. So 6, 3, 3/2, 3/4, and then 3/8. Find the 7th term of the geometric sequence whose first term is 5 and whose common ratio is -3. So first term is 5, then it'd go -15, 45. How many is 7th? Then it would go -135. And let's go -135 times -3. So 405. And notice it's an alternating series when what we're multiplying by is negative. So times -3, that's -1215. How many is that? 1, 2, 3, 4, 5, 6. And we want one more. So we're going to go times -3. Here's the 7th one, which is 3,645. Now we also could have used a sub n is equal to a sub 1 times r to the n minus 1. So a sub 7 is equal to, a sub 1 is 5, and then we're multiplying by -3 each time, and to the n minus 1, that'd be to the 6th. So 5 times -3, and we need to use parentheses, -3 raised to the 6th, and you can see we get the same exact answer. Because we took the first term and we multiplied by -3, 1, 2, 3, 4, times -3, 5, and times 6 to get this one. So to get the 7th term, you actually multiply by 6 -3s, not by 7. Write the general term for the geometric sequence. Then use the formula for the general term to find the 8th term. So a sub n on this one is equal to 3 times, that's a sub 1, and we're multiplying by 2 each time. So that's 2 to the n minus 1. And we're supposed to find the 8th term. So 3 times 2 to the 7th. So 3 times 2 to the 7th. That's 384. Find the sum of the first 9 terms of the geometric sequence. Find the sum. All right, S sub n is equal to a sub 1 times 1 minus r to the n over 1 minus r. So S sub 9 is equal to a sub 1 times 1 minus, what we're multiplying by is -3. -3 to the, how many terms? 9? 9 terms. Over 1 minus -3. And that's 2 times 1 minus -3 to the 9th. And let's get that top value. Let's get the numerator. And then we'll divide that by 4. 9,842. Find the following. So S sub 8 on this one is the first term. We need a sub 1. Now when we plug 1 in for I, we get 6. The first term is I. 1 minus, now what we're multiplying by each time is 3. That's the r. So 3 to the 8th over 1 minus 3. So 6 times 1 minus 3 to the 8th. And we'll divide that by -2. So 19,680. A job pays a salary of $30,000 the first year. During the next 29 years, the salary increases by 6% each year. What is the total lifetime salary over the 30-year period? So S sub 30 is equal to a sub 1, which is 30,000, times 1 minus 1.06 to the 30 over 1 minus 1.06. We have 30,000 times 1 minus 1.06 raised to the 30th. Let's get the numerator, and then we'll divide by 1 minus 1.06. And we end up with 2,371,745, and let's go 59 cents. Find the sum of the infinite geometric series. The sum of an infinite geometric series is a sub 1 over 1 minus r. Now the absolute value of r has to be less than 1 in order to have a sum. So a sub 1 is 3 in this case. A sub 1 is 3, and r is 2/3. Now the absolute value of 2/3 is less than 1, so this has a sum. Now the way we got 2/3 is you take 2 divided by 3, and there's where you get the common ratio, what you're multiplying by. The sum is equal to, a sub 1 is 3 over 1 minus 2/3. Now what I would do to finish this one is I'd multiply everything by 3. And the reason I'm picking 3 is because of that fraction right there. And this will get rid of the complex fraction. We have 9 over 3 minus 2. Those will cancel, leaving 2. So the sum of this right here, the sum of all those is 9.